The talk about Lico 3237 alternate tab simulation give us an integer window, which is our initial permutation of the number 1 to n. And we have an integer array query. So for every query, it will just simulate the alternate tab simulation that we are going to bring those number into the top. So after all of these queries, let's look find the final state of the tabs. So what does that mean is that, for example, initially we have window 1, 2, 3, that is the initial state. And now we query 3, right? So we are going to bring 3 into the top. And now our tab window is like 3, 1, 2, right? And then we query 3 again, right? This 3 is still at top. Then we query 2. So what happens is that we're going to bring this 2 into the top. So it will be 2, 3, 1, right? So how can we do this question, right? So we know the last query will always bring a tab into a top, right? So we'll see the result will be 2 because this will be the last query, right? So apparently this will be the top. And then we look at from the last reverse order, we try to see 3, right? 3, if we already been placed, that means we have a query later have 3, right? Then it will do nothing here. But here you see this is the first time we do from the back to query, right? So that means we'll see forward direction that the last query that will take effect, right, for these 3. And so we'll see we can place 3 in this result. Then this query we will see these 3 already being replaced by a later 3, right? So this one not take effective anymore. And so we'll see in these windows we already have 2 and 3 being placed in the final state, but 1 has never been queried. So we just put this one in on the behind, right? So our process is that we look in a reverse order for the query and place the query part, and then put all of the numbers which didn't been queried on the later part, and for the final result. So we need weighted array for this number, right? So for the weighted array, what we do is that um, we we iterate for the queries in a reverse order. And for example, these 2, it doesn't weight, then we can put that into our result, right? And 3 didn't weight it, we put it on our result. And then reverse order, we see this 3 again, right? This is already weighted. Then for this query, it doesn't do anything. So we just continue, right? And also this weighted array can help us to range the original window, right? So we'll see the 1 is not being weighted. Then we place 1 here, 2 and 3 already been weighted. Then we do nothing here, right? So in this case, we compose our final result. So let's write this process into code. We are going to have n equals Windows total length, right? So we need a Boolean visited equals new Boolean. Here the things that this number they are not they are not zero. They are from 1 to n, right? So we can have this Boolean to be n plus 1, right? So we always set, for example, visited 0 equals to true, that will never touch this 0 anymore, right? Then or whatever, if we don't set this one as true, when you in the second part, you just iterate from 1 to n, right? So so let's do the first part is for int I equals let's have this m equals corridor size, queries dot length, and we can have an index equals -1, right? So for I equals m minus 1, I greater equal to 0, I minus minus, we're going to have int q equals queries I, right? So if visited q, we just continue. Otherwise, we are going to have results um, this one equals q, right? And then we are also set q equals true. Then what we do is that for every interval in these windows, right? So we'll place those didn't visited. Um, Actually, we don't need this because for these windows there is no 0, right? So this line we can skip. Then if visited v, we just continue. Then otherwise we just have result index plus we just return result, right? Results. So, uh, so we'll see this query. If we have m queries and there are n numbers, so this will be an OM operation, and this is an ON operation. So time complexity will be m plus n, and space will be an ON, right? We can also convert this to Python code. Let's have n equals the length of windows. Then we're going to have visited equals false multiplied by n plus 1, right? We're going to have result equals this one multiplied by n, and we're going to have index equals -1. So for q in reverse, reverse queries, then we're going to have if visited q, we just continue, right? Then what we do is that we're going to have index which is plus equal to 1, and result index which is equals to q. Visited q should equals true, right? And then we look at the window for v in Windows. We're going to see if visited v, we should continue. Otherwise, we need we have index plus equal to 1, right? And result index equals to v. So in the end, we return results.